Let's talk about Leslie matrices. So Lewis talked about two that can go on the end of your exam, dominance and Leslie. We've just done dominance. Leslie matrices are another thing we can do to apply what we know about matrices. Leslie matrices are used to model populations. So we use what we know about some species, or we go and survey what we know about gerbils or foxes or dingoes or whatever it is, and then we use some matrix arithmetic to model what's going to happen and make predictions, and do we need to worry about them, etc. So suppose, okay, the textbook's example is hamsters. For us to use the Leslie matrix, we break it up, break the lifespan of this thing up, this animal or whatever it is, into groups. Typically, first year, second year, third year, fourth year. So, we might have, for example, hamsters, and we might go age and number of female hamsters. We might go, this is the age at the end of the year. So for the first year, we maybe discover we have 48 of them. And the 2-year-olds, we have 42. And 3-year-olds, we have 26. And 4-year-olds, there are 12. And we don't find any hamsters older than 4 years old. We need two more kinds of information. We need survival rate and fertility rate, which for Leslie matrices is called fecundity rate. So that name's about to come up. Let's talk about survival rate. You know what? Can I put them in the same table? I'm going to put two more columns in the same table. I'm going to go survival. Is that a question I need to answer? Are we okay? All good? Survival rate and something called fecundity. Did I even call it rate or just fecundity? Fecundity rate. So survival rate is what proportion survive to the next year. And 1-year-olds it's 0.7, 2-year-olds it's 0.5, and 3-year-olds it's 0.3. And I'm not giving you information for survival of 4-year-olds because we didn't find anyone older than that, so we assume nobody survives. Comfortable so far? And the other information we need is fertility, fecundity. Fecundity is the meaning is the number of female offspring per female hamster per year. So how many children is each hamster going to have? Of 1-year-olds, about half give you someone. 2-year-olds, they're very fertile. 3-year-olds, 0.8, and the 4-year-olds, 1 in 5 might have a baby hamster that year. So what we're going to do is put this information into a matrix, actually into two matrices, and we're going to use it to make predictions about the future population. We're going to make a Leslie matrix. All right. My Leslie matrix. Okay. My Leslie matrix looks like this. It's going to be 4 by 4 because we're going with 4 categories. Across the top, I'm going to put the fecundity. I'm going to run out of room. Shouldn't have closed my matrix yet, should I? Where's my rates are gone? 3.1, 0.8, 0.2. And then down the diagonals underneath, I'm going to put the survival rate. And when we multiply it out, you'll see why I did that. Everywhere else is 0. Let me get my colours. Oh, they're here. Got to get used to this. Fecundity numbers went along the first row, and survival rate went down the diagonal. Everything else in that matrix is 0. You can remember which one goes where, because you will only have 3 survival rates, but you'll have 4 of these. So the one where there's fewer spaces to put them has to be the survival rate. Why does this work? Because I'm going to start with an initial population, a number I have 0. It was meant to be a subscript, didn't look like a subscript. Is 48, 42, 26, 12. Maybe I should show you where they came from too. Because watch what happens when I go my Leslie matrix times the number I had to start with. Let me write it out for you. 0.5. You don't have to write it out each time, but I want to show you the first time exactly what's going on. 0.7, 0.5, 0.3. (48, 42, 26, 12). Wait till you're all ready to watch.
When we multiply, do we round down?
Don't round yet.
Alright.
Round at the end, when they say after 10 generations, round at the end.
Okay, because if you've got like 3.8 hamsters...
Correct. But this is a model.
Hmm.
Round when you interpret that into a number of hamsters after so long.
Yep.
Don't round too soon. Do everything in your calculator with big matrices. Let it worry about all the accuracy you need. And round at the very end. So watch what happens when I multiply these two matrices. And I'll make sure you're watching. Lily's nearly ready. What, Travis, you ready?
Yep.
What happens when I multiply this? Half. This is the fertility rate. How many 1-year-olds do I get the next year? Half times the number of current 1-year-olds. 3.1 times the number of current 2-year-olds. 0.8 times the number of current 3-year-olds. That gives me the first row of my answer, which is the number of 1-year-olds the next year. How many 2-year-olds the next year? 0.7 times the number of 1-year-olds only. 0 times all the rest. How many 3-year-olds do I have the next year? Half the number of 2-year-olds and nothing else. That's why that works. So if I get my calculator and do that, you'll have an approximate number of hamsters in each year group the following year. That's why this works. Yep, get it, practice.
But when we're giving our answer, we always give the floor of the number.
It's an approximate model. You can round.
Okay.
So the numbers you actually get from this, are they actually the nice numbers in the textbook? I don't think they are.
Oh, mine are decimals.
What did you get?
177.4.
177.4.
33.6.
0.6.
21.
21.
7.8.
7.8. That's my N1 vector. If I want to ask, the most common thing I'd ask is, how many hamsters are there after 1 year? Number of female hamsters after 1 year is approximately, there's my key, add these up, round off,
Okay.
is what I would do. They might ask you more specifically, how many 2-year-olds are there, then round this number. It's a model, it's approximate, it's a guess. So how many is there total? Make me do this, 210, 211, 232, 241, 240?
I'll check it.
Here's the trick here, you can go sum, open bracket, your this matrix, close bracket, it'll tell you the total.
239.8.
Not bad. So I'm going to round it off, 240. But I can go much further very easily.
Like years in advance.
Yeah, what about in 10 years' time? All I need is L10, which is going to be N10, which is going to be. So the number after 2 years is going to be L times the number after 1 year, which is L times the number after 0 years, right?
Mm-hmm.
Which is L squared.
So whatever number.
So the number after 10 years is going to be L to the 10 times the number I started with. Work it out for me. How many hamsters are there after 10 years? All tech active. That's what I was saying before. Keep raising this matrix to whatever power you need.
Okay, I don't know, I've got really big numbers.
Well, I mean, we're getting about 4 point something new hamsters for every one hamster. So I'm not surprised you're getting big numbers.
No, like 41,000. Oh no, that was like the sum of all of them.
Oh, okay. What were the numbers?
There's a lot of decimals. Do you want me to just...
Give me 1 or 2 decimal places.
27491.38.
Oh, you know what? That's good enough.
Yeah.
Okay, let's just go approximately. Yep.
10850. 2956. 509.
509.
I don't know if I did it right though.
And so you can then just add those up and get about 41,000 hamsters. Make sense? The hardest bit of doing this is getting this matrix correct. What do I need to say about this? Okay. In this process, what kinds of assumptions am I making? Because if you have to evaluate the reasonableness of this answer, how do I know? What kinds of assumptions am I making in all of this? Yep?
That the survival rates won't change.
That the survival rates are constant. Yep? Is that real? Is that true in practice?
No.
Probably not. A lot of other factors are going to affect it. What else?
Fecundity rate.
Yeah, this is a fixed number. It's probably more fixed than this, but it's still going to depend on a lot of things. I was thinking kangaroos and wallabies, if the weather is no good, they just hang on to what they've got and don't actually let their embryo develop yet.
Like turtles too, if it heats up.
Yeah. So that's an assumption, definitely. What other kinds of assumptions are we making?
What if, like, I don't know, like when they get 5 years old, if there are some.
Yeah, what if we occasionally get 5-year-olds? Our model ignores them. Are they going to be fertile? Probably not. So it probably doesn't make a big difference. But we can make that kind of guess based on these numbers. We're assuming that they don't get taken away, or go to some other island, or some natural disaster doesn't come in and wipe half of them out in one go, some bushfires. Yeah, there's lots of assumptions here. I mean, we can make the same kinds of assumptions here too. Like dominance matrices, if I play against that other team, does the outcome of that only depend on who's a better team?
No.
What else might it depend on?
Injuries and whatever.
Are you a home or away game?
Yeah.
Again, you can change this model, or in fact this model, to make adjustments for those kinds of things if you need to.